alarms go off when I enter the building.
We interrupt the scheduling broadcasting tonight for an ABC News special report. Hello, welcome to ABC News tonight. I'm your host, Jake Hess. There's been a development in the Middle East tonight. A garden snail has taken on the ability of super speed. We take you there tonight. Here's Jake Hess. Thanks, Jake. Good evening, America. Tonight we bring you to Baghdad, where we have arranged a private meeting with the subject. We have given him a private name to ensure his safety and his well-being. His code name is Turbo. Good evening, Turbo.
Good evening.
Can you tell us how you got your powers?
No, not really. All I know is that I fell on some sort of nitros.
Did you feel different afterwards?
Yes, I felt faster.
And there you have it, America. That's Turbo's account of his story. So now we visit Dr. Hess at the University of Purdue to see what happened and what went wrong. Dr. Hess, can you tell us how this could have happened?
Certainly. It is a very long process. Turbo's DNA has to be mutated, but how? Normally, he would be a slow, ordinary snail, but through a deletion mutation, his genes have been changed. To further understand, we must know the basics. In the central dogma, DNA is transcribed to make RNA, and from there, RNA is translated to make a protein. Translation is a process of making an RNA copy from a DNA template. This is similar to DNA replication. So RNA polymerase binds to a promoter on the DNA strand to signal the beginning of a gene. Then, the RNA polymerase makes a complementary strand from one of the exposed DNA strands called template strand. Finally, RNA polymerase comes across a DNA sequence called a terminator, which stops the transcription process. The three parts of the process are initiation, elongation, and termination. Now, the gene is ready to be translated. Translation is the process in which the ribosome reads the mRNA and makes a protein. Transcribed mRNA directs the translation process. In a eukaryotic cell, transcription goes on in the cell's nucleus. Translation is carried out by the ribosome in the cell's cytoplasm. It begins at AUG and positions AUG to attract UAC. So it binds together to create an amino acid and then continues down the line until it reads UGA, UAA, or UAC, which are stop codons. This creates polypeptides, which are the proteins in the snail's body. Now, made correctly, these can be very beneficial for the snail to perform normally. But something went wrong with our snail.
Well, what went wrong, Doctor?
Well, he had a frame shift to the gene UAG, CAA, UCG, AUA, UUG, and the single gene had the C removed, so it had a frame shift, so it read as AUG, AAU, CGA, AUA, and UG. It left the UG out, which is very important to the snail's slow-moving gene. So now, instead of reading slow, it read super speed. So that is how he goes, so fast.
Thanks, Dr. Hess. No problem, Jake. So that's it for tonight, America. I'm your host, Jake Hess, bidding you farewell and have a great night. Good night, America.
Ah, 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 ah.